Hello there, mathematicians. This is the last objective of the unit. Man, time flies when you're having fun. Okay, and this is actually a really fun objective. Today's objective is students will be able to graph linear equations. So go ahead and get that down. Alrighty, let's start with the steps. Okay, we're going to give you these steps and then make sure that you use these as we do each problem. Okay, so step number one, okay, is we are going to box the b. Okay, so parentheses plus or minus the b. Now, we should know that the b stands for, and you should have said in your head, the y-intercept. So we're going to box the b, and then let's just say and plot. Okay, step number two. Again, if I'm going too fast, just hit pause. Step number two is look at sine of slope. Let's say, so plus show with pencil. And I will explain to you what that means in a second. Okay, step three is we are going to do from the y-intercept. Okay, we are going to do the slope. So we're going to do m equals rise over run, and then we're going to do a fraction. Okay, and we're actually going to do, and I like to call it reverse. So if you continue this step down here, and then we're going to say reverse slope. Okay, and again, I'll show you what that means. Okay, all right, let's hop in and do a few examples. I'm actually going to start with example 2 because example 1 is kind of tricky. I'm going to start with a more basic one. So we're going to follow the steps. Let me zoom in on this bad boy here. Okay, we're going to follow the steps. The first step that I said that I was going to do is I'm going to box the b. Okay, I'm going to box the b. Let me flip that. Sorry, didn't mean to make that little line over there. Okay, so let's box the b. You don't need to make this line over here. That has nothing to do with your notes. Here is the b, including the sign. So we are going to box the b. Now, that is the y-intercept. So let's write that down. That is the y-intercept. Okay, that tells me on my y-axis where the line is going to cross. And it is going to cross at positive 1. And I know it's positive 1 because it's plus 1. So the first thing I'm going to do is box the b and plot the point. On the y-axis, okay, I'm going to plot the positive 1. And if you need to put a little note here showing that this is where we got this from, okay, go ahead and do that. All right, so that was step 1. Now, the second step is look at the sine of the slope. Okay, the sine of my slope is negative. So negative slope. What is that going to look like on the graph? Okay, is it going to look like a line going up and to the right or a line going up and to the left? And the answer we should know is it's going to be a slope that goes up and to the left. Okay, so from this point, we need to go up and to the left. That's really important to keep in mind. Okay, one of the most common mistakes is to just have the line going the wrong direction. Where, like, if it's a negative slope, you just make it a positive, where your line goes up and to the right. Okay, we have to avoid that mistake by looking firsthand to see what our slope is going to look like. We know our line should go up and to the left. Okay, all right, here's where the second part comes in, or the third step, I should say. Okay, the third step is we need to, let me zoom out just a hair. We need to write the slope. So I'm going to come underneath. Again, my slope is m equals rise over run. Okay, which is equal to. Now, this is really, really important. Okay, our slope is negative 2. We can write any number as a fraction over what? So if I had to write this as a fraction, any number I can write over what? And the answer you should be saying in your head is 1. Okay? So my slope, my rise, is -2. And my run is +1. Okay? So let's just go ahead and graph this because I want to show you how we would do it. Okay, if we look at this, my rise is negative. Okay, my rise is negative, right? Do you think a negative rise means up or down? And the answer to this is it means down, right? A negative rise means to go down. Down, so we're going to go down 2. Okay? Now, my run is +1, right? A +1 for a run, remember that's the x-axis. Do you think we're going to go to the right or to the left? Well, if it's positive, we're going to go to the right. So we're going to go down 2 and right 1. Okay, so let's go up to our point. Let's go up to our point, our y-intercept. Again, we always start from that y-intercept. Okay, I'm going to go down 2. So let me change the color here. So I'm going to go down 2. So 1, 2. Okay, and if you want, you can still do these loops if you want to count that way. But there's down 2, and then I said right 1. Okay, there's a point. We don't put the point until I finish my rise and my run. Guess what? You can keep going. Okay, I'm going to go down 2 again and right 1. Okay, keep going the entire length of the graph. Down 2, right 1. Can I go any further? Can I go down 2 more? No, because you'd be off the graph, right? We don't need to go off the graph. Okay, so far I have that. We're off to a good start. Okay, but you see all this room in the upper left-hand corner? I need my line to go up there too. I don't just want a line that's halfway. I don't want a line that's just like this, right? And we know we're going to have arrows at the end. And yeah, we could use a straight edge, and you guys should definitely be using a straight edge whenever you're making lines. Okay, we could use a straight edge and just go all the way up, but we need points to show us what goes all the way up. Okay, here's what I like to call throwing it in reverse. Okay, reversing the slope. Okay, and it's really important that you look at how we do this. Okay, let's go back down here to our slope. We had -2 over a +1. Okay, if we reverse that, all I need to do is switch the signs of both numbers. Okay, so it was a -2. I'm just going to rewrite that. -2 over 1. Okay, I just got that from here. When I reverse it, okay, all I'm going to do is switch the signs. Okay, and let's put it underneath it. Switch both signs. Okay, so we're going to just switch both signs. So, my fraction, it was a -2. It turns into a +2, right? The 1 was a +1. It turns into a -1. Okay, so if you want, you can draw arrows just showing that all we did is just switch the signs of both numbers. All we did is switch the signs of both numbers. Okay, here's why this is so helpful. If I go back up here, so let's do this real quick. So if I have a +2, okay, am I going to go for my rise? Am I going to go up or down? Well, I'm going to go up 2. Okay, and if I have a -1 for my run, remember my x-axis, my run, I run left and right. Okay, I'm going to go left 1. Okay, so now we can go back up. Always start back at your original y-intercept. And I said that I'm going to go, I'm going to use blue on this, I'm going to go up 2, 1, 2, and then left 1, 1. Okay, don't put your point until you go the rise and the run. So again, it's up 2, left 1. Okay, can I go any further? The answer is no, I cannot. Here is your graph. Okay, and mine's not going to be straight because it's really hard to draw a straight line on a computer, but you should be using a straight edge for this. Okay, guess what? You just graphed a linear equation. We just graphed a linear equation. If you're stuck on it, why don't you go through one more example with me, and then if you're still stuck, you can rewind it. I'm actually going to go on, all right, we'll stay here. Let's do a tricky problem real quick. Let's do this tricky one. Okay. Y equals 2. You should notice something something a little bit different about this one. And what you should notice is that it doesn't have an x with it. Okay? No x. Okay? And we know that the number in front of x is always our slope, right? It's y equals mx plus b. So if I write out y equals mx plus b, okay, there is no x here. This is gone. This is absolutely gone. So what do you think the m was to make this x disappear? Well, one answer we should know is it was probably this, okay, plus b. Because I know that 0 times x is going to give me 0. Do I need to show y equals 0 plus b? No. Okay, so I'm just going to have y equals b. Okay, that's how we got an equation that doesn't have a regular slope. Okay, now the other way that I can start off by putting a point at 2 on the y-axis. Okay, now the other way that I can think about this, if I have any ordered pair, any of them, okay, and again, you have unlimited, infinite ordered pairs if you're talking about a line. Okay, the y value in this ordered pair is always what number? Look at it. It says y is 2. The y value in each of these ordered pairs is always 2. Okay, now the x can be any number. It doesn't say anything about what the x is. The x can be any number. So what's it going to look like if the y value is always 2? Well, we could say x is 2, right here. And then the y in the ordered pair would be what? 2. So I go right 2 and then up 2. Okay, we could say my x is 6. And then my y is still going to be, my y is always positive 2, so always up 2. No matter what the x, the y is always positive 2. So we are always going to go up to positive 2. What do you notice this is forming? This is forming a horizontal line. Okay, this just formed a horizontal line. And we know that the slope of a horizontal, this all makes sense. Think about this. We know, if I gave you this the other day, you would say, oh, Mr. Aaron, the slope of that, 0, right? And then if you plug that in right up here, okay, and I already showed you this, if you plug in 0 for the slope right up here, well, what's 0 times x? 0. What's left? Just your b. Okay, so this makes sense that the excuse me, that the equation for this line is just y equals 2. Okay, so I want you guys to put a key point in your notes. Okay, that if, so key point is this: if y equals number, and then we should say with no x, I know that it's going to be, it will be a horizontal line. Okay, if I just have y equals a number with no x, it's going to be a horizontal line. Okay. Get that down. If you have any questions, you can hit rewind or hit pause. Alrighty, let's keep the good times rolling. We have a few more examples. We're going to step up the difficulty in some of these here too coming up. Okay, I'm just going to follow my steps. Okay, I want you guys to actually make sure you're using a pencil in case you make a mistake, but I want you guys to do step 1. Okay, so go ahead and do that now. Okay, step 1 you should have had. If you don't have it yet, hit pause and wait till you do it before you hit play again. Okay, but step 1 you should have boxed your B. Okay, make sure you include the sign. I want you guys to write this. Include sign. Okay, really important that you do, because that tells us it crosses the y-axis at -2. So I want you guys to put a point at -2 on the y-axis. Okay, and you should have put a point right there. Okay. The most common mistake is to accidentally put that, and don't do this, is to accidentally put that point right here. Okay, this is on the x-axis, not the y. We don't put the point on the x-axis. Okay, step 2 is look at the sign of the slope. Okay, you should see that it is a negative slope. Okay, right away in my head, I'm thinking, oh, well, I know a negative slope goes up into which direction? Up into the left. So I know my line had better look something like that, where it goes up and to the left. Okay. All right, so the next thing I need to do is write out my m equals rise over run. So m equals rise over run. Now I'm going to write out my fraction. Okay. Here's something really, really important. Everyone on your calculator, okay, do this. So grab your calculator. Do -3. So here's what I want you to do on your calculator. -3 divided by -5. Okay. What do you get when you do that? Well, you get a positive, right? Is our slope a positive? And the answer is no. This is not right. You don't do a negative over a negative. What you do is you assign this negative to either the 3 or the 5. Because if you do this, I want everyone, again, grab your calculator. Everyone do this. -3 divided by 5. That's an ugly 5. -3 divided by 5. And you get a negative answer, right? I think it'll get you -0.6. Okay, now on your calculators, I want everyone to do a +3 divided by -5. What do you get? You get the exact same thing. Okay, these two fractions are equivalent. They're the exact same. Okay, when we have a negative sign out in front, we assign that negative to either the 3 or the 5, but only one at a time. Okay, so let's start off. Let's put that negative with the 3. And then it goes over a +5. Again, I only assign it to 1. Okay. Now, I'm going to go ahead and graph this now. The -3 over 5. So my rise is -3. If a rise, meaning the y-axis, is negative, do you think we're going to go up or down? Well, it makes sense. A negative, we're going to go down, right? So I'm going to go down 3. So 1, 2, 3. I don't put a point yet. I just keep my pencil right there. And then my run is +5. Now, here's also where I look at over here, right? My line should go up and to the left. So if I start going this way, and don't do this, just watch. If I start going this way, right? If I start going this way, and then I think I'm going to connect those points, I know right away that that's off, right? Because that's not going to be the negative slope. So I know, yeah, it's a +5, so I should go right. But I know that I should go right anyway, so that my line turns into a negative. So I'm going to go right 5. So 1, 2, 3, 4, 5. There's my point. Okay. Can I go any further? The answer is no. So here is where I say, let's reverse the slope. Okay. I got all this graph up here that I need to change. So this is equal to, when I reverse it, instead of putting the negative with the 3, the -3 turns into a +3. Okay? And the +5 turns into a -5. Okay? So now my rise is +3. And if you want, you guys can do this using a pen or some different color. That way you really see the difference. Okay? So my rise is +3. Okay, so I'm going, positive means go up. So I'm going to go up 1, 2, 3. And my run is -5. So I'm going to go left 5. 1, 2, 3, 4, 5. Boom, there's my point. Okay, I can't go any further because I'll be off the graph, so now I'm just going to connect these. Okay, now I don't think I said it on the last one. We've worked with lines before. All of our lines should have arrows at the end. Because technically, right, we could keep going up and to the left, up and to the left, on forever and ever and ever. So that's why we'll put arrows at the end of the lines, so that that line goes on forever. Okay. If you have any questions, again, hit pause, rewind it so you can go back and look. Okay, let's go on to another example. Example 4. You guys should be able to do this based on what we just did. So I actually want you guys to do this, and then when you're done with it, follow the steps, and then when you're done with it, hit the play button, and I'll have the answer already there for you. Okay. So go ahead, hit pause, and solve this problem now. Okay, here is my line. Now, I want to show you guys a common mistake that sometimes does happen because you get off on your counting. let's say I accidentally put a point right here, and don't write this down, but let's say I accidentally put a point right here. Okay, and I'm going to make my line, I'm going to make my line, I look at it, whoa, no. What happened there? Dead giveaway, you graphed a point wrong. Okay, if you ever get to where, okay, these are linear equations, meaning they form a straight line. This bend right here does not form a straight line. So if you ever have a point, say maybe you had a point like right there. If you ever have a point that's off the straight line, you know you did something wrong. So you want to go back and look at this point and you know it's off. It should have been right here. Okay. So again, that's always a good way to check and make sure you put the arrows. Okay, that's always a good way to check to make sure that you graphed all the points correctly. Now, one other important thing, if you look up here, okay, my positive 1 turned into a negative 1. My positive 2 turned into a negative 2. And you may be saying, well, Mr. Irwin, that's not the same thing. Okay, well, everyone on your calculator, if you don't believe me, do negative 2 divided by negative 1. And you're going to notice the answer is equal to a positive 2. Okay, these two are the exact same fraction because a negative divided by negative turns into that positive. So we're not changing the value of it at all. Okay. All right, let's keep moving. Yay, some more difficult problems. Okay. These aren't difficult. This is what we just did the other day, right? Converting things to slope-intercept form of the equation. So, but I can promise you, I will trick some of you on this, okay? When we do this one, we cannot graph, and let's put this key point. Okay, let's put this key point. Okay, that we cannot graph until in slope intercept form. And slope intercept form we know is always y equals, right? Y has to be solved for, has to be by itself. If we look at this one, y is not by itself. Okay, if we look at it, it's y plus 4. So what's being done on the same side of y? Well, I just said it, plus 4. How do I undo addition of 4? Subtract 4 from both sides. Okay. Now, and you guys should have a little bit more room than me, I'm just going to bring it down here and write it. So my equation is y equals 2x minus 4. Okay. All right, go ahead and graph this equation. Make sure you follow the exact same steps. You guys, once you follow the steps enough times, you don't even think about following steps. It just becomes so easy. Okay, so follow the steps, hit pause, and when you have it graphed, go ahead and hit the play button, and I'll have the answer for you. Okay, if you didn't notice by now, this is the exact same equation as right up here. Y equals 2x minus 4. It just wasn't solved for y, right? It looks a little bit different, but your graph should look the exact same. Okay, hopefully you saw that. All right, one more example. This one is a little bit trickier as far as converting it to slope-intercept form. We did some of these the other day, so why don't you guys actually try to solve this one for y on your own? Make sure you're using a pencil. Go ahead and hit pause and solve for y. Convert it to slope-intercept form. Hit pause now. Okay, I'm going to solve this. You guys can just watch to make sure that your work looks the same. If you don't have a same step as me, make sure you erase what you have and start doing it again, or rewrite the problem and solve for y again. Okay, so I asked myself, what all is being done on the same side of y? And I always start, what's touching y? Well, I have a 2 touching it, but it's not just a regular 2. It's a negative 2. Don't forget that sign. Touching means multiplication, so I am multiplying by negative 2. How do I undo that? I need to divide by negative 2. What else is being done? Well, I have a positive x hanging out on the same side. And you guys keep in mind, do we ever care about the sign after x? If you were thinking in your head, oh, it's negative x. No, the minus is after the x. We only care about the sign before. It's a positive x, right? How do we move a positive, and we could say positive 1x if we want. How do we move that to the other side? We need to subtract 1x. Which one do you do first and why? Well, you need to do the subtraction first because reverse GEMDAS. Okay, we always start with addition and subtraction when we're solving because we use reverse GEMDAS. Okay, so I would subtract 1x from both sides. Why can't I just say, oh, 6 minus 1x is 5x? You should have been saying to yourself, they are not like terms. You know that. Okay, now I need to bring down, make sure you bring down this negative sign. Negative 2y is equal to 6 minus 1x. Now, I'm also fine if you guys want to rearrange that now and say negative 2y is equal to, oops, I'm going to have to come up here. I ran out of room. If you want to come up here and say negative 2y is equal to and rearrange it, keep the sign on the x. It's a negative 1x. Keep the sign on the 6, which is a positive, so plus 6. If you want to rearrange that now, that's fine. Okay, I like to just keep it simple, keep it the way it is, and I'll rearrange it at the very end. Okay, so I just finished this. Now I just said I need to divide by negative 2. Divide by negative 2. Now here's the key, and I showed you guys this work the other day. I like to really show my work, separate those terms, and then divide both of these by negative 2, because you have to divide this entire right side, right? Divide both of these by negative 2. Okay, now let's look at this. Negative 2 over negative 2 cancels to be 1, so that just leaves me with 1y, or just y. Okay, positive 6 divided by negative 2, positive 6 divided by negative 2 will get me negative 3. Okay, negative 1 divided by negative 2, well, a negative divided by a negative is a positive. So I'm going to write a positive, I can write as a plus 1/2 x. Okay. Now I can rewrite this to be in slope-intercept form where the x comes first. Okay. So I'm going to keep the 1/2 x, and what's the sign with the 1/2 x? I'm just going to kind of circle this to show you the signs. So it'd be y equals positive 1/2 x. And then what's the sign on my 3? Negative. So it would be minus 3. And you guys really should in your notes make sure you show where we're getting these signs from. Okay. Now you have just a regular slope-intercept equation that you can graph. Okay, so go ahead and graph that. Hit pause and I'll have the answer when you're done. Okay, that is what you should have. Y equals 1/2 x minus 3. Okay, 2 more quick examples. Again, you know, this objective isn't real hard. It takes a little bit of practice. But the, whoops, I didn't mean to do that. But the trickier part of all of this is some of these problems that look a little weird. Okay, and these are the types of problems that you will see on the ACT. Okay, all right, example 7 says x equals negative 4. Well, this one's really tricky because I know to graph I need slope-intercept form, y equals mx plus b, right? Okay, this one doesn't even start with y. Okay, but you guys, just like example 1 from the previous slide, okay, we know it tells us that the x is always going to be what? Okay, the x is always going, no matter what the ordered pair, the x is always going to be negative 4. The x will always be negative 4. It says right there, x is negative 4, always. Okay, the y can be any number. You can say it's 1, you can say it's 5, you can say it's negative 3. Okay, so if we graph any of these points, an x of negative 4, okay, so I would go left 4, so 1, 2, 3, 4, and then for this first one I would go up 1. That's my first point. Let's just call that point A. Okay. For point B, I would go left 4. Oh no, I got off on that, didn't I? Cross that one out. I can't erase on mine. You guys can. Actually, erase it on your paper. I can't erase on mine. I need to go left 4, right? That was 1 off. Okay. And then negative 4, 5. So I go left 4 and then up 1, 2, 3, 4, 5. I don't know. You guys are counting, saying, did you do it right? I think I did. Okay. And then the other one, negative 4, and then down 3, because it's negative 3. So negative 4 and then down 1, 2, 3. what do you notice it's forming? You notice it's forming a vertical, and I got off, and you know, again, my arrows aren't straight on this computer. It forms a vertical line, okay? Really quickly, I want you guys to write down the slope of this line, just for fun, just for practice. Write it down. What's the slope? Quickly. You should have said the slope is, if you go skiing off this cliff or sledding, you are going to die. So it's, you can't even define how much fun it was because you're dead. So it is undefined. Undefined. Okay, that was just for practice. Okay, last one. Yeah, go through this quickly. Y equals 2x. Keep in mind, my slope-intercept equation is y equals 2x, or I'm sorry, y equals mx. You guys can erase. Y equals mx plus b, right? If we look at this one, do I have the m and the x? And the answer is yes. Okay. Do I have the b? No. That tells us that the b was actually plus 0. Okay. They just didn't write it. So let's put a key point that we don't have to write, that we don't write the plus 0. Okay. So if there's no b, we know it crosses at 0 on the y-axis, which 0 is the origin. That's where it crosses. Okay. And then your slope is just m equals 2 over 1. Again, we can write any number over 1. Okay, how would I reverse the slope on this? Well, it was a positive 2, now it's a negative 2. It was a positive 1, now it's a negative 1. Again, that's just reversing the slope. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Now, instead of going up 2, right 1, I'm going to go down 2, left 1. Again, instead of going up 2, right 1, I'm going to go down 2, left 1. So down 2, left 1, down 2, left 1, down 2, left 1. One more time. Okay, and then connect it. You guys should be using a straight edge. Don't forget the arrows. And boom, you just graphed it. Okay. So really quickly to recap, some of the trickier problems are this. Okay, and you guys can write this. So if we have y equals like 5x, okay, it is going to have a slope. Okay, it's going to be something like that. If I have like y equals 5, okay, it's going to be a horizontal line. And if I have something like x equals 5, it's going to be a vertical line because the x is always 5 on this one, the y is always 5 on the second one, and this one has a slope, it's just the y-intercept, and we should actually draw this. The y-intercept is actually the origin. Let's draw out these coordinate planes quick, because I think that'll help us. So here are my lines on here. Ooh, got thick. So again, here are my lines. Okay, that's just kind of a little cheat sheet reminder. All right, you guys will have plenty of practice. You will absolutely have to know, this is like a fundamental thing. Slope and equations and graphing, fundamental things of algebra. So, got to get this down. Have fun practicing.